GATE 2013 electrical question number 12. The curl of the gradient of the scalar field defined by V equal to 2x square y plus 3y square z plus 4z square x is, four options are given. So we need to find the curl of the gradient of the scalar field. Now you need to know some useful information in order to solve this question. Now you need to know the gradient of a scalar valued function. This gives the maximum rate of change of the function at that point for which gradient is taken. So what I mean to say is that if this is the scalar valued function and this is the point for which you are taking the gradient, now by gradient I mean to say this operator. So if f is a scalar valued function and if you take the gradient of that function, which becomes a vector field, okay, this becomes a vector field, denotes the maximum rate of change of the scalar function, which is like this, at that point for which this gradient operator was gradient operation was done. So if this is the point for which the gradient operation was done, then the level surface to this point for this scalar function, at this point this gradient will be normal to the level surface and will give the maximum rate of change of the function f, scalar function f, at that point p. This is the gradient for f at p, and this is a vector field and this is a vector because there will be many such points, so it becomes a vector field and this gradient is a vector. Now this operation can be seen as, if this is the case, then dou x of f I cap plus dou y of f j cap plus dou z of f z cap or k cap. Now if you see curl gives the rotational tendency of a vector field. Now you see always gradient always is a divergent vector with no curl, that is no rotational tendency. So by the question they are asking us to find curl of this gradient of this vector field. So curl of any vector field can be like this, curl of f, this we say curl of f, and this will be like this when f is a vector, where f, you can say f naught. So f naught is a vector field. Remember, the gradient operation is done on a scalar field f, where f is a scalar field, but curl operation is done on a vector field f naught. So f naught is a vector field, and if f naught is a vector field like this has some rotational tendency, you just place your right hand along the direction of the rotation and then your thumb will point in the direction of the curl. So curl is into the plane, so it has some curl, non-zero curl, because it has some rotational tendency. So if it has some rotational tendency, curl will be non-zero, but this divergent field, the vector, is divergent, so it does not have some rotational tendency. The curl of gradient of a function will always be 0. So this is a point to note, and this is the geometrical interpretation given for this problem. So curl of gradient of a function, that is a scalar function obviously, will always be 0. Similarly, I am writing it, curl of gradient of a scalar function is 0. Similarly, the divergence of curl of a vector function or vector field, that is, first you do curl of a vector field and then the divergence of curl of a vector field is always also 0. So these 2 points you need to remember. So the answer is option D. So option D is the correct answer for this problem. Thank you.